All right, here we go. We are finishing up page 47. We had done a couple of these, but I want to do these last two. Make sure we remember what's happening. Okay. I start right here. We are used to that because it's parentheses and that's where we start. We draw a picture. Yesterday I gave you rules for the inverse notations, remember? I said if that number is positive, everything is in quadrant 1. Now, I did not give you rules for the cosecant. I gave you sine, cosine, and tangent. But you know that cosecant is the reciprocal of the sine, so the same rules apply. Okay? Quadrant 1. Hypotenuse is 3 and opposite is 2. How do I know that? So, Katoa. Sine is opposite over hypotenuse, so its reciprocal will be hypotenuse over opposite. Does that make perfectly good sense?
Sure, that makes perfectly good sense.
Then I can do my Pythagorean theorem and come up with this guy right here. So you do that. A squared plus b squared equals c squared. Remember the hypotenuse is c. The hypotenuse is always c.
Root 5.
Square root of 5. Perfect. Now, it is possible that if I were in a different quadrant, that root 5 would be negative. Does that make sense to you? If my picture were drawn over here, then I would have to make my root 5 negative. That happens, not here. All right, perfect. What do I want to know about this?
Tangent.
2 over root 5. Done. Easy peasy.
Wow, we got some extra.
Cosine
Double parentheses.
Okay, so now I've got a negative number. Anybody remember where I draw an inverse sine negative?
4.
4. So I'm going to draw my triangle in quadrant 4. And the opposite is -1 and the hypotenuse is 5. Please remember that the hypotenuse is always positive. The hypotenuse will never be negative. That can be negative and that can be negative, but that will never be negative, okay? All right, do your Pythagorean theorem and tell me the missing side.
Or no, it'll be negative. It'll be root 4. Negative.
A squared plus b squared is c squared.
Oh, I
A
did
squared plus 1 is 25. A squared is 24. 2 root 6? Yeah, I can't fix that, folks. You gotta know how to do the Pythagorean theorem. Okay? That's on you. Now, what do I want to know? I want to know the
Cosine.
cosine. What's the
Adjacent.
cosine? Adjacent over hypotenuse, so it will be 2 root 6 over 5.
So that extra parentheses
Separates the negative. Okay? Now, I'm going to check that one on my calculator. So I know that when I do it on my calculator, I'm going to get a decimal. It's not going to look like this. It's going to come out as a decimal. So I want to see what is the decimal form of this number. So 2 square root 6. Oops, I put divided by 5. That's 0.979795. Now, be careful when you type that in. If you didn't get that number, you probably forgot to close the parentheses around the 6. Your calculator automatically puts those in, but you have to physically close them. All right, now, let's type that in and see if we get the same decimal. Cosine, second sine, -1 divided by 5. Oh my gosh. This is called the decimal or the approximate answer. This one right here. And this right here is called the exact answer. So when someone tells you to answer exactly, then you know you are to answer with no calculator, by hand, basically. Okay? Now, for purposes of time, I am ending this right there. I'm not going to do those 2 word problems. We're going to move on. We're going to do a little bit in 4.8, and then we're going to review for our results. So, 4.7 is due Friday.
Tomorrow.
We might do a little of that too if we have time. So let's do a couple of these word problems, okay? 4.7 due on Friday. Do a little bit of 4.8, do a little bit of that homework for you, and do some review. All right, here we go. Number 1, draw a picture, write an equation, solve it. We've done these before. There are some harder ones in here, but these first few, we've done these already. Earlier in this very chapter. In fact, there could be a quiz question tomorrow because every one of these was in the quick review. We have a bird in the top of the tree. I want to find the angle of elevation. The bird is 18 feet above the ground. Where do I put the 100? The top of the angle of elevation of the bird in the top of the tree. From a point on the ground, 100 feet from the base of the tree. Where does the 100 go?
Ground.
Right here.
The adjacent. This side.
Okay, what do I do? Equation, tangent x. Remember, tangent has an angle hooked to it. In this case, my angle is x. Tangent x equals 18 over 100. Now, don't multiply by 100. What do? If you have to find an angle, we're going to go straight to our calculator and do what? Inverse tangent, yep. If you are looking for the angle, you must use your inverse functions. Do not do any math. Just go straight to the calculator and inverse it. And what do we got? Inverse tangent, 18 divided by 100. Did you get 10.20? And that would be degrees.
You put it in degrees because you're looking for the degree, right? Like, is that how you figure it out? Which one you're using?
These directions do not tell you to put it in degrees. Normally in the word problems, we are in degrees, but if you put down a radian angle, I couldn't mark it wrong because it didn't
Okay.
tell you. We want to know the angle. How you measure the angle is up to you. Normally it's degrees.
Okay.
So if you got point something as your answer, then it's probably a radian. Now the next one, I have to be in degrees because problem B literally says your angle is 24 degrees. It says that in the problem. Now we've got a worm on the ground, we got a bird in the tree. And the tree is 19 feet tall. And what do I want to find? Eli? You kind of, Betsy, I know. And you just, I'm on video, so I'm not gonna say what I'm thinking. Here we go. Find the distance from the worm on the ground to a bird in the top of the tree. Would everybody agree that's what I'm looking for? I got my angle's 24, my tree is 19. And I want to mention one more time. It says the angle of depression. This is actually the angle of elevation, but it matches the angle of depression, so we always put it right here. Whatever kind of angle it is, elevation or depression, is right there. Okay, sine, cosine, or tangent. Sine 24 equals 19 over x. Now, don't use these buttons, right? Not this time. I'm going to multiply by x and divide. 19 divided by sine 24, that is a degree, so make sure you're in degrees if you want 4. 46.71 feet. That sound okay to everybody? Last easy one, then they're gonna get a little harder. How tall is a flagpole? It casts a 23-foot shadow when the angle of elevation is 32 degrees. Where is my x going to go? Oh, I already got my x. Where is my 23 going to go? 23 is here on the ground, yeah. Sine, cosine, or tangent? Tan 32 equals x over 23. Multiply by 23. Type it in. $14.37 feet. How does that sound? Good? All right, let's see what the next one is. Kirsten places her surveyor's telescope on the top of a tripod 5 feet above the ground. All right, so here's the ground. Here's the tripod, 5 feet. Here's the telescope. She measures an 8-degree elevation above the horizontal to the top of a tree that is 120 feet away. How tall is the tree? So first, are you with me here? Does this make sense to you? Where do I put the 8 degrees? I have an 8-degree elevation. Where am I going to put that? Do you know? This is her line of sight right here. Wouldn't that be the 8 degrees right there? Where do I put the 120? Down here? And won't that also be 120 right here? Could I solve for this blue thing right here. Can I figure out that blue thing? Using my triangle? So let's see, that would be tan 8 equals x over 120. So x equals 120 tan 8. Okay, well, let's do that. So the blue thing is 16.86. Add 5 because I want to know the entire height of the tree. So the answer to the problem is 21.86 feet. Just a little bit of an added complication, not a hard problem. Anybody have a question about something we did there? All right, a couple more. Here we go. Number 3. A U.S. Coast Guard patrol boat leaves Port Cleveland and averages 35 nautical miles per hour, traveling for 2 hours on a course of 50. Okay, wait, this is getting complicated. So here's my compass. Here's Port Cleveland right here. That's my starting point. On a compass, remember these are your labels. We haven't talked about this in a while, but those are your labels on a compass. Those are not the labels we use in regular math, but on a compass, that's what we use. All right, he's on a course of 53 degrees. So would you agree that 53 degrees would be kind of like this? Would you agree with that?
Yeah.
Now, he's traveling at 35 miles per hour. Now they're nautical miles, which means they're a little bit longer than regular miles, but it's just a speed. Knots are speed, nautical miles per hour. So he's going 35 miles an hour for 2 hours. So how long is that black thing I drew right there? 70 nautical miles. When you get in your car and you drive 50 miles an hour, those are called statute miles. And statute miles are used when distances are relatively small or short. So when you're in an airplane, think about it now for a minute. When you're in an airplane and you're flying from the United States to Germany, let's say, you're flying like this, aren't you, in an arc? So those are miles, but they're nautical miles because they're arc miles, not straight line miles. When I drive to school, that's a straight line. But when I'm going all the way across the ocean, like boats and ships do, that's not nautical miles. Okay, so now the ship is right here. So I'm going to go ahead, or the plane, whatever it is I've got, I'm going to set up another compass. Because now he's switching gears, switching direction. And he's going to go on a course of 143. Would you agree that 143 looks like this? Remember, we're measuring from here, so there's 90. But this is 180, and I'm not getting that far. So 143 looks like that, right? Now, how long is the pink one? Well, he's going for 3 hours at the same speed. So that would be 105. So that one's longer. And now the boat's right here. Would everybody agree with that? Okay, what's the question? What is the boat's bearing? That means he's like his course. What course is he on? And how far is he from where he started? So this is what we're looking for right here. he is from port. In chapter 5, we're gonna be able to handle any triangle they throw at us. But right now, the only triangles I can deal with are right triangles. That's all I have right now. So let's think about this for a minute. If this angle right here is 53, would you agree that this one is also 53? I am asking you to dig back in your memory alternate interior angles. These are parallel lines. That's a transversal. That's 53, that's 53. Now, this is 180. If that's 43, then what would this part right here be?
Of the whole thing?
This is 180. This much of it's 143. What would this much of it be? 37? So this angle right here between black and pink is 53 and 37. What does that make? 90. There's your right angle. There's your right triangle. Now again, in a couple weeks, that ain't gonna be 90. That's gonna be something else. But we'll know how to handle it when the time comes. But now I have a right triangle. I am missing this side. How do I find the third side, the missing side in a right triangle? Pythagorean theorem. So 70 squared plus 105 squared equals x squared. So 70 squared plus 105 squared. And then I'm going to square root that. I got 126.19 nautical miles. So how far is our ship from where he started? 126.19 miles. Now I'm going to find this angle right here, the red one. I'll call it Y. Would you agree that the tangent of that angle is 105 over 70? Look at my picture. Remember, that's a right triangle. This is the hypotenuse. So this side would be opposite. And this side would be adjacent for that angle. So how do I figure that out? What do I need to do? Yeah. So inverse tangent. Uh-oh. Siblings. I don't know how to do it, but I'll do it like it. 56.31. Everybody okay with that? Okay, now remember, this ship has done the black and the pink. Now he's stuck out here in the ocean somewhere, and we're gonna send this rescue boat out on the blue to get him. We know the rescue boat's gonna have to go this far to get to him. We have to give him a direction. Directions are measured from due north. So his direction will be this angle right here. So how will I find that? I'll take 53 and add 56. So his heading is going to be, what is that? 109.31 degrees. So we're going to tell him to follow a course of 109.31 degrees for 126 miles, and he will find the boat.
So that's the bearing.
Yeah. When, think about it, Have you ever heard somebody say directions, they say, come to the intersection and bear right? That means direction, bear right, that's what that is.
So that's the answer.
Yes, both of them are the answer. So the distance is 126.19, and the direction is 109.31. All right, that's enough for now. We'll stop there. We'll finish this up next time. And what I'd like to do
I just like
is have you get out your 4.7 homework. In our 4.7 homework, which you haven't done yet, or maybe you have, I don't know. And I'll let you pick. I'll do 2 problems for you. So in the 4.7 work, pick 2 of them. Which 2 look scary? 1C. When you see notation like this right here, that means that you are finding an angle. So basically what this problem says is, find the angle whose sine is 1/1. So somewhere out there, there's an angle whose sine is 1. Now if you think about it, it's not going to be a triangle, because you can't draw a triangle that has opposite and hypotenuse be the same. Does that make sense to you? If I can't draw a triangle that makes sense, then I am going to draw a circle. Now, if that had been 1/2, I'd be fine. But 1/1 won't work in a triangle. So I'm going to look around my circle. I'm going to go ahead and write them all down. And I want to find the angle where if I put y over r is 1, I get 1/1. Well, where does it happen? Start here at 0. Does it happen here? No, wouldn't that be 0/1? How about up here? Does it happen here? Now you're looking at y. Sine is y. You're looking at y. 1? Good. So the answer to the problem is pi over 2 radians or 90 degrees. How does it say the answer? Okay, so pi over 2 will be your answer. All right, I'll do one more.
Can we do 1B?
1B says, same kind of thing, where is the angle whose tangent is 0? Now, think about what that triangle would look like. If you want the triangle to have a tangent of 0, then would an opposite have to be 0 and adjacent be 1? Can you draw a triangle like that? So we're back to the circle. Here we are. Any zero will never be a triangle. Does that make sense to you? No sides are ever going to be 0. So if you have a 0 in your problem, you're heading straight for the circle. Now this is a tangent. Tangent is y over x. So let's start right here. If I put y over x, do I get 0/1? What? Y over
Oh, yes,
x.
yes.
So that's my answer. What angle is that? 0. That's where it starts. That's 0. So the answer to this problem is 0. Okay, I might as well do number 1. no zeros in that one, so I'm gonna have a triangle, but I need to know where to draw the triangle. It's an inverse cosine negative, quadrant 2. So this triangle is in quadrant 2. You guys, there are certain things that, I mean, there's rules. And for the inverse cosine, a negative number moves you to quadrant 2. Okay? Positives are always in 1. What do I know about it? I know that the adjacent side is √3 and the hypotenuse is 2. Which means that is a 1. So in degrees, this would be 30. But a 30 is a 6th of a pi. So this is pi over 6. But be careful, that isn't the answer. This is the answer. So if all the way to here is a whole pi, but this is a 6th of it, then all the rest would be 5/6. And the answer is 5 pi over 6. All right. I put that aside. You can do the rest of it on your own. Thank you, Mrs. Ford, for doing my homework.
Thank you.
All right. Now, get out the quick reviews from yesterday. Did anybody look at this last night and say, boy, I hope she has another one of these? No. Kind of low-hanging, you have to show me how to review. Jimmy,
The second review, number 4.
second review, find the area that's shaded. Okay, so that one, I'm gonna make up a different problem. Jimmy wants to practice a problem where you have to find the area of a sector. Okay, so we're gonna find the area of this sector, piece of pie. And what we are given is the radius, I'll make the radius 5, and we're given the central angle, I'll say 160 degrees. Okay, there you go. And your job is to find the area of the shaded part of the circle. Does anybody remember what we did yesterday? So we have to figure out what fraction of the circle is shaded. So the whole circle is 360. So this is the fraction of the circle that's shaded. Would you agree with that? So that fraction of the whole thing is what's shaded. Okay, so I'm going to read these. That's 16 over 36 times the area of the whole. Well, what's the area of that whole circle? Pi r squared, which would be 25 pi. Okay, I already reduced this a little. I can reduce it more. That would be 4/9. Yeah, 4/9 times 25 pi. So 100 pi over 9. And Jimmy, if this were inches, that would be square inches because it's area.
Okay.
That make sense? All right, did you find any more as you were studying?
That was my big one.
When you're tired, you don't have to.
No, no,
Can we get one like 1 on?
Jade has her hand
Oh,
up.
sorry.
Wait, so 100 pi over 9 is the answer?
Yep.
But if we like could have, if we were able to reduce it, we would reduce it.
Yes, yes. We reduce everything, but that doesn't. So, all right, what was your question?
We're graphing one.
When I give you a graph and you come up with an equation,
Yes. You can.
all right, let's see. So that guy right there could be a sine curve, or it could be a cosine curve, right? So I'm gonna write one of each.
Are we gonna have to do anything with tangent? No, because tangents do.
No, the picture would look different if it's with a
Yeah.
tangent.
I just didn't know if they were
I'll do a tangent, but not, it's not part of this. That's either a
I wanna
sine
see
or
tangent.
cosine.
Yeah.
So there are 4 numbers that impact your periodic functions. You have this number, which is your amplitude, and for this problem, it is a 4. Now, I'm gonna build, I guess, my sine equation first. If I build my sine equation, then I am choosing to look at this right here. Now, could you look at something else? Absolutely. But I gotta do something, so I'm just gonna do the red. Would you agree the red is a sine? And if I do the red, then that has to be a negative. If you chose to start here, then yours would be a positive 4. Do you see that? Okay, I'm choosing here, so I'm doing that. This number right here tells me how far I have shifted horizontally. We call it phase shift. Since I started my sine over here and not here, which is where it should start, this is going to be x plus pi over 11. Since my picture doesn't look very good, but I'm oscillating between -4 and 4, I haven't lifted it up. Because if I lifted it up, I'd be oscillating between -3 and 5, or something like that. My axis would be something other than the origin, or the x-axis.
Is it always gonna be like the opposite thing? Like for the pi over 11? Would it always be like how it's on the negative side, but then you changed it to plus?
Remember, yeah, that's a left shift. We talked about that back in chapter 1.
Okay.
This goes left. Now, the only thing I'm missing is this number. I'll call it n temporarily. What does that number do? In the equation, what does that number right there do? Divides the period. The period of a sine curve is supposed to be 2 pi. Clearly, this is not 2 pi. But 2 pi divided by that number gives me my actual period. What is my actual period from red dot to red dot? How far is that? What is it? 4 pi over 11. So 2 pi divided by whatever that is gives me the actual period of the problem. Every time. Sine or cosine. Every time. So now I have to solve for it. So 22 pi equals 4 pi n. Divide by 4 pi. Pi's cancel, what do I have? 11 halves. So this number is 11 halves.
And why do you change it to addition? Can you explain that?
No. This, when you're doing a horizontal shift, a plus goes left, a
Oh, okay,
minus
that's
goes
why.
right. Yeah,
Okay.
it's what we did back in chapter 1 when we were moving all those trapezoids and things around. Okay, so there's my sine equation. Erica?
So if they gave you like the 11 over 2 or the n, how would you find the period? Like how would you switch it around to find the period?
2 pi divided by that number gives you your period.
Okay.
So if they gave me that number, 2 pi divided by that number is my period. Okay? Now, when I write my cosine equation, it's going to be exactly the same, almost. This is still going to be a 4, this is still going to be 11 halves, and this is still going to be 0. The only thing that's going to change is the horizontal shift, the phase shift. Because if I'm thinking of this as a cosine, I'm starting somewhere else, right? I'm starting at either the bottom of the hill or bottom of the valley, or the top of the hill. I chose to start here, which again makes that negative. And, oh, guess what? Is that where it's supposed to start?
Yep.
Yeah. So there's no horizontal shift if you start there. Now, if you started over here,
Is it allowed to start there for some?
then that would be a positive, and that would be minus 2 pi over 11. How many possible answers are there to that problem? Oh my goodness, infinitely many. Because if I'm doing a cosine, I can start my cosine here, 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 here. Yeah, I can start my cosines infinitely many spots.
At the top, like, do we only use 2 pi and 4 pi? Or those two?
Exact same graph.
You have to make.
Oh, yeah.
That's what, how many points do you have to have like 5, or how many do you have to have?
You have to have a full period.
You have to have a full period.
Which is.
For, would, negative cosine start at the bottom?
Yep, so that's why I made this negative, because I'm starting at the bottom. All right, let's do one more of those, because that seems to be problematic. And part of the issue there is, guys, those problems were one of your e-learning assignments. So those of you that didn't bother to do that, you're paying the price now. And how much sympathy do I have? None. All right, let's see. Negative pi over 5.
What do we, oh, you gotta do that.
Try.
14.
Where are you? Okay, so you gotta move it a little bit, move it to the left, because it's, well, 6 foot jump.
You're gonna make this.
Oh,
I love jump.
I'm like 7.
I think I got
I
this.
get so tired of the concept.
I do like leading. Everyone does leading every time. Like on an extra day.
Well,
Yeah.
Okay. All right, here we go. I think I got it.
What page is that?
All right, here we go. Let's start, it doesn't matter, let's start this time with a cosine. It doesn't make any difference, we'll start with the cosine. So I'm gonna choose to look at this as my cosine. Would you agree that that's, okay, I can do that? So that would be a positive cosine with an amplitude of 1/6. I'm starting at 11 pi over 20 when I should be starting right here at 0. So that's my phase shift. I appear to have no vertical shift again. And if there's going to be a vertical shift, this will not be your axis. It will be moved up or down. The only thing I'm missing is that problematic period number. So what do I remember? I remember that 2 pi divided by that number, I'll call it n, 2 pi divided by that number gives me my period every time. Period is beginning to end. Now, I'm not doing my cosine because I don't know what this end point is and I want to figure it out. Is this one hill and one valley right here? So I can get a period right there. So -1 to 14 is how far? 15/5. And 15/5 is 3 pi. So my period is 3 pi. So 2 pi divided by something has to be 3 pi. So 2 pi equals 3 pi n. It looks like this time that number is
2/3.
So now when I do my sine curve, this is still gonna be 1/6, this is still gonna be 2/3, and this is still gonna be 0. The only thing that's gonna change is where I'm starting my sine curve. Well, I'm gonna choose to start it right there. Right, that would be a nice little sine curve. So this is gonna be, first of all, that's positive. Up first, so positive. And my phase shift is negative pi over 5, which means x plus pi over 5 to move me to the left.
It's just hard to graph.
Okay? All right. What else from yesterday's review? I'll just throw one up here. There we go, solve it.
That'll solve 2x.
Divide 2.
Well, first I would add the root 3,
Which will then give you.
and then I'll divide by 2. This is a no calculator problem, and it tells me that I have an angle adjacent over hypotenuse is root 3 over 2. That's what that says, right? So how big's the angle? It's not 60. The angle is 30. And 30 is pi over 6. But guess what? You only got half credit. These problems have 2 answers. So you ask yourself, where else can I draw a triangle? It's here, 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 where the cosine will be positive.
Top left.
Bottom right.
Here, will cosine be positive up here?
Yeah. Oh, no.
Guys, cosine is x. Cosine is adjacent. Is that gonna be positive over here?
There, bottom right.
Quadrant 4. Now, it's the same angle, so that's pi over 6. That little angle right there, same angle. But I gotta go all the way around.
I don't know how to do the whole.
11 pi
All the
over
way
6.
around is confusing.
Like how they're like, how does he know to put them at the bottom?
Because
All the
12
way around.
over 6 would be
Positive
2.
root 3 and a positive
Because
2. You choose
6 is 1
But if it was over on the left, it would
Well,
be
and what?
negative 3.
Still, yeah, I'll figure it out.
It's because we're in 6.
I'll figure it out one day.
All right, one more here. Suppose I give you an angle y, 4 pi over 7. And I say find an angle coterminal with 4 pi over 7.
Add 2 pi.
Add 2 pi. Or subtract 2 pi. Whatever flips your switch. Now, if it says find a positive one, you'll want to add 2 pi. And when I add, I get a common denominator. So one possible answer would be 18 pi over 7. Right?
Yeah.
If we were in degrees, we wouldn't add 2 pi, we would add 360.